Welcome, students, for electrostatics problems. You are learning some techniques to solve electrostatics problems. So here is the next problem, that is 2-point charges 8 microcoulomb and minus 4 microcoulomb and 8 microcoulomb are separated by a distance that is 10 centimeter in air. At what point on the line joining the two charges is the electric potential zero? So here is the most important problem where you are supposed to calculate at a point where the electric potential will be zero between the two charges. Where it is charge Q1, this is charge Q2, and you will calculate the distance at which the charge potential is zero. It means the potential of these two charges at a point where it is zero. If the total distance between the two is r, we will consider, let's suppose we will consider a distance between the two charges, that is x, where the potential might be zero. So here it is. This is the charge Q1 given. This is the charge Q2 given. And the distance between the charges R, that is 10 centimeter, it is 0.1 meter. So let P be the point of the zero potential. Here we consider that this P is a point between the two charges where the potential may be zero. It is situated at distance R from Q1. It is the distance R from Q1 x distance. This is the distance x from Q1 distance. The total distance between Q1 and Q2. We need x distance. So Q2 will be at a distance r minus x. That is, the total one is r. This is at a distance. P is at a distance x from Q. Then Q2 will be at a distance of r minus x from Q2. So here is it. As point P, the total potential will be zero. So we have to consider the distance of this charge particle at point P and distance of Q2 from this one. So here it is potential at 1 and 2. This V1 and V2 must be equal to 0. So here is you are calculating potential at distance x, this one, and potential at this, that is r minus x. If this one is the total one r, this one is x, then this one will be r minus x. So the distance of the charge particle, division of the charge particle, that is r minus x. Here it is. Then it is equal to 0. If you simplify it, that is minus q2 divided by r minus x. Then you have simplified it, that is r minus x divided by x, that is equal to minus q2 divided by q1. And these charges are given, q2 and q1 is given. So if you look at, that is 1, simplify it, r over x, x over x, that will be 1. And it is equal to this one, that is 0.5. And this one is minus 1, here it will be plus 1, it will become plus 1.5. So if you take the, you have to calculate the value of x, but the point potential was you have considered 0, that is 1 over 1.5 divide 0.66, because you have to calculate the value of x, so that's the you have taken as a total. So multiply by the distance r, and the distance r is basically 1 meter, 0.1 meter. So after multiplication, we have calculated the distance in meter, and it is 6.6 centimeter. So if you look at, then the total distance is 0.1 meter. Here will be the distance at point O at the distance x. So after simplification, it is 0.033 meter. So r minus x, the distance which we calculate, whereas refers to the total, that will be 0.33. So thus the point P is situated at the distance 6.6 centimeter from Q1 and 3.3 centimeters from Q2. So this will be the position between the two charges where the potential will be 0. So after applying the basic condition we have calculated. So it's very simple, long, but looks long, but it's very simple to understand where will be the position between the two charges where the potential is 0. So here you have placed this large particle at point P, and after placing this large particle at point P, you have calculated the distance of Q2 from P and Q1 from P, and the total distance between the two charges are R. The position of this charge particle from Q1 is X, and the position of this Q2 from the hole will be R minus X of this position. We have calculated the potential at both of the points, and then finally we have calculated the value of X here, and then we have concluded virtually the distance between the two position of the two. Here it is 6 centimeters from the Q1, and it will be at 0.33 centimeters from Q2. With this, I thank you very much for your attention.